confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. Is the audio clear, Induja, or are you facing an issue? I hope the audio is clear for everyone. Yes? Okay. So that means whosoever is facing an issue, kindly refresh it. Okay, refresh your connection. Okay. So now we continue with the portion of the northern plains. So here we had seen, or we have already seen, the concept for the formation of the northern plains. That how is it that the northern plains got created? So there you had the theory of four deep, or the concept of four deep, which was provided by Edward Seuss. And what Edward Seuss basically said that look, as the lands they compressed against each other, that you had the Indian plate and the Eurasian plate compressing there, while the upfold would create the region of Himalayas, you had a simultaneous downfold created at the same time. And that downfold over the years would basically be filled by the sediments brought by the various different rivers. And that is how you had the creation of very vast and fertile sedimentary northern plains in existence. So here, now, when we take a look at the feature of the northern plains, overall, they are formed by the alluvial deposits brought by the rivers. That is what is together in geographical terminology also referred to as the Indo-Brahm river system, right? So that is the Indus, Brahmaputra, and river Ganga. So it is the tributaries of these particular river systems which end up accumulating all the deposits that you see created in the region of the northern plains. Now here, they extend close to around 3,200 kilometers from east to west. And these northern plains, they are widest in the west, widest in the west, and get narrower in the east. So that is why in the region around the upper Gangetic plain, or the Indo Gangetic plain that you have in the region of Haryana and those areas, there you will find that the width of the plain region is very significant. But as you come towards the region of Bihar, Jharkhand, and West Bengal, by that point of time, you will find that the northern plains, their thickness or their width reduces quite significantly for that matter. Okay, so here the average width of the northern plains is roughly around 150 to 300 kilometers. The maximum depth of alluvial sediments varies up till around 2 kilometers from the surface. So till that depth, you have the sedimentary deposit which is observed. Now, here, it is not the case that in the entirety of the northern plains you will have the same kind of material dominating that. Even when you talk about the cross section of the northern plains, there also the types of deposits they tend to vary. For example, immediately at the foothills of the Himalayas, you will find very large deposits in the form of rocks and boulders. That is what is the Bhabar tract. Then after that, you'll find fertile but very marshy and muddy Tarai region. That is followed by the alluvial plains. This is the alluvial plain. This is your alluvial plain. So there also you have the older deposits in the alluvial plain. They are named differently, and the newer deposits. We'll take a look at this concept. So first of all, let us understand how is it that across these northern plains, across the cross section as you come from the region of the Himalayas all the way till the northern boundary of the Peninsular Plateau, you have varying different types of deposits. Why does that happen? So let us take a look into that. So first of all, let us assume that here you have the presence of mountains in the form of the Himalayas. Okay. Now, immediately at the base of the mountain, here, as the river starts to move, at this point, when the river is in youthful stage, its carrying capacity will be very, very high. So, while it is hurtling down the slope and coming down the slope with a very high velocity, there, what do you come across? The fact that the rivers are able to carry with them large rocks, boulders, all these pieces, the rivers are able to carry along with them. But as soon as you hit the base of the mountain, where you come across the flat piece of land, obviously the rivers won't have the ability to carry those materials anymore, the large rock pieces, etc. The river won't be able to carry that anymore. It will start dumping it almost immediately. That is why in this region, you will come across those particular deposits of larger rock pieces, etc., that the river would have carried. Larger rock pieces, boulders, etc., that the river would have carried. Okay. Because the river won't have enough speed or enough velocity to possibly carry them any further. So they simply dump it out at the foothills. They dump it at the region of the foothills. Now, this particular dump of the at the foothills, when you observe all these larger rock pieces, boulders, etc., getting dumped there, this is what is also referred to as bhabar. This is the bhabar tract. Now here, when taken a view from above, let's suppose you are taking a top view. Now, in case of top view, it is only the rocks and the boulders which will be visible to you. The river and the flow of the river would be hidden underneath these rocks and boulders, right? So that is why you would be hearing the sound that the river makes, but you won't be able to get that visual perception of the river actually moving. So that is why it is commonly said that the river disappears underneath the rocks. It does not disappear, it simply stays hidden underneath these particular rock systems. And then after that, here in this particular Bhabar tract, think about it. Can you carry out agriculture here? Obviously, no. Cultivation cannot be carried out. So here, no agricultural cultivation, but obviously, in a few areas, you will find a couple of trees growing there, here and there. But overall, you won't find a significant amount of cultivation being carried out in this particular region or in this particular area. Now, after that, the river then appears to re-emerge into the plain region, and into the plain region where it flows into an area where there is no predefined channels for flow. So predefined channel means you have a pathway for the river to flow. So in this area, the river won't have any such channel in which it will flow. So multiple different smaller streams, they diverge from the river. Multiple smaller streams. Okay. These will start to diverge. And eventually, in this area, the river water will be diverging itself into so many different types of streams, so many different numerous smaller streams, that the entire region, in terms of water sufficiency, becomes quite significantly water sufficient and oversaturated in many cases also. So this is the region where you will have very muddy, marshy conditions of the soil. Very absolutely moist conditions of the soil is something that you will observe. And then eventually, this comes back. Eventually, you'll find that as it proceeds further into the plains, these will basically come back. And then, furthermore, this will be the in a predefined and a predetermined river channel where they will be flowing. So this particular tract, this particular area, this is what is referred to as the Tarai belt. This is your Tarai belt. Very, very fertile because moisture is also available. So it is very fertile. Heavy presence of moisture and water. So you will have luxurious growth of vegetation, very heavy density of vegetation, trees, etc. You'll find to be present in this area. Okay, so obviously in this area, if the vegetation is very high, you will find the presence of the various different types of wildlife as well. The animals and their diversity will also be significant. Now, it is a different matter altogether. Now, when you talk about the Terai belt, it would continue from the region of Uttarakhand, then into the northern portion of Uttar Pradesh, and all the way up till the Assam region. Now, all this area would be densely forested. It was only during the British years, that is in the 1800s, when you had a large scale deforestation of trees and forest of this area, which was carried out. And that was carried out for the single purpose. So, when you had the massive level of deforestation which was carried out, at the end of it, as a consequence of it, you did not have any amount of vegetation which could support wildlife. So there was a significant toll on the wildlife population as well. Otherwise, historically, this was the area which was dominant in rhino population, dominant in the tiger population. These were very abundantly found. But then, when the Britishers started deforesting the area, they started deforestation because of two reasons. First of all, they wanted or they required the wood to make up the sleepers that you have for the railway tracks, right? So for because railway tracks were being laid out across the country, and in between the railway tracks you required wooden sleepers to be placed. So for that, deforestation was carried out. Secondly, also for manufacturing of paper. For that also, large scale and massive level of deforestation was carried out. So because of that, Tarai belt has been deforested. Now, after this, when the river flows, then it will carry out its deposits on the sides. Okay. It will carry out the deposits on the sides. And that is what we have as the alluvial plains. This is what we consider as alluvial plains. Now, even in the case of alluvial plains, it is not as if all the deposits would have happened at the same time. For example, what I mean by that is basically, if you think about these alluvial plains and their cross-sectional analysis, it will have a representation somewhat like this, where let's suppose this is your river channel. Okay. This is the adjoining plain region. So, in the region of the river channel, you have obviously the river water which flows. Now, as the river flows, then it will carry out its deposit immediately here on a regular basis. As the river flows, it will carry out regular deposits in this region. But let's suppose when we talk about the rivers, they historically they would have flooded quite significantly over a very large area. It might happen that once every 100 or 200 years you have such a massive flood which covers a very large area. Now, if let's suppose we consider one of such incidences where 50 years back or 100 years back, when the river would have flooded, it would have flooded the entire region of the floodplain. the entire region of the floodplain would have been flooded. So, as a consequence of it, there would have been deposits which would have been carried out when the entire region would have been flooded. So deposits would have been carried out in these areas, very far away from the river channel, where on a regular basis you don't experience that flooding, but the flooding would have happened a lot earlier, right, in these areas. So there, the deposits, they don't get replenished year after year or in various seasons. It is only when once you have had this flooding, then all these areas receive that deposit. And then as the flood waters have now receded, that area doesn't get deposit anymore, right? So this is the older deposits which have been carried out much earlier. So these are your what are referred to as the older deposits carried out by the river. So these older deposits, they are known by, these are your older deposits. These are known as bhangar. Whereas these are your newer deposits, which are carried out on a regular basis. So this is your newer deposits, carried out regularly on a very regular basis. So these newer deposits, they are known by the name khadar. Khadar is always going to be much more fertile. It is going to be very, very fertile. Whereas when we talk about bhangar, because it is a deposit which has been carried out long time back, so it is not going to be very fertile. So this is going to be very fertile. Okay. Whereas when we talk about bhangar, they have been deposited such a long time back that most of the nutrients, they are basically taken away. And in the older deposits, you will also find that the size of the particles, the grain size is larger. So here you will find coarse grains, larger grain size of sediments. Okay. The sediments have very large or a coarse grain size. So that is by Bhangar. So in Bhangar, when you have all these old deposits, many of the times, why is it that you have the larger grain size? Is because many of the times, under the weight of these deposits themselves, the lower portions, they will emit, or because of the pressure, imagine this, you have significant amount of grains, right, lot of them, now they get deposited on top of each other, so they will be imposing the weight on the bottom. So the bottom ones, oftentimes under that pressure, they secrete the calcareous liquids that are generally present in the soil, and that ends up joining with the other ones. So that becomes a joining factor by which these grains, they combine with the other ones. So that is when eventually the small ones, two or three of them, they will join together to form the large calcareous concretions. And those are what we refer to as conchers, right? Conchers are something that you would have heard generally in the colloquial language of the northern plains. You would have come across the fact that whenever the grains are basically accumulated, the conchers are separated. So these are your large stony calcareous concretions which are present in bhangar. So bhangar is not fit for cultivation for many type of crops. For example, here at max you can grow pulses, maize, or millets. These kind of crops you can grow. So suitable for crops such as maize, pulses, and millets. Whereas when we talk about khadar, khadar is basically suited for all various different kinds of crops, especially when you talk about jute, when you talk about, let's suppose, the crops such as rice, paddy cultivation, cash crops that you have, sugarcane, etc. Everything can grow particularly well here. So that is where here you will find suitable for all kind of crops. Crops like jute, paddy, etc. Okay, so that is something that you will observe as a feature of the northern plains. They are also named differently depending upon the region. For example, you have the upper Gangetic plain in the region around western UP, parts of Haryana, that is the upper Gangetic plain. Then in central UP and some parts of western Bihar, it is referred to as the middle Ganga plain. And then in the region of West Bengal, eastern Bihar, that is the lower Ganga plain. So that is what is also referred to as the Rad plains. The lower Ganga plains, they are also referred by the name of Rad plains. Okay. So that is something which you will observe as a nomenclature in these particular areas. Okay. Khushkaran, is this class a live stream of the offline class happening in real time? Okay. So this class is a live stream of an online class which is going at this particular point of time. I don't know if that satisfies your answer or your query. So Rad plains, that is the name given to the lower Ganga plains in the region of West Bengal. Lower Ganga plains. They are named as Rad plains. Their naming is Rad plains. Okay. Now then, here, if we take a look at Bhabar, so it is a narrow belt of 8 to 10 kilometers, almost parallel to the foothills of the Shivaliks, that is the outer Himalayas. And the river disappears in this zone as they deposit the heavy boulders, the rock pieces that we have talked about. So it, when we say that the river disappears in this zone, it is simply the fact that the river and the flow of it is hidden by the rocks deposited on top of it. That's it. Okay. So the river and the flow of it, that gets hidden. So the rivers deposit heavy materials of rocks and boulders, and the area is not suitable for cultivation. For example, when we talk about the rivers, such as if ever you happen to venture into the area around Rishikesh, and if you drive further uphill from the area of Rishikesh, you will observe this Bhabar tract. And even, in fact, right between Rishikesh and Haridwar, there also you will find the presence of this particular deposit of Bhabar tract. So Bhabar is where you will find only stones and boulders. A river is moving somewhere in between that. Most of the river is hidden, and odd one or two trees here and there is also something that you will be able to figure out. That's it. Okay. Now, not suitable for cultivation or agriculture whatsoever. Okay. Now, after that, here, immediately to the south of Bhabar, when the river re-emerges, it re-emerges into an area where you have those significantly fertile land, but you don't have a predetermined channel through which the river will flow. So all that water that the river is carrying, it simply diverges in the form of multiple different streams which drain that area. And that region becomes marshy and swampy, super saturated with water. And that is the region which is referred to as the Tarai belt. Okay, so that is what you have as the Tarai belt. So when you talk about the Tarai, it is to the south of Bhabar. Streams and rivers re-emerge without any properly demarcated channel, and marshy and swampy conditions, they are known as the Tarai. So here you will have a luxurious growth of natural vegetation and a variety of wildlife. For example, the Corbett Tiger Reserve that you have, for example, the Dudhwa Tiger Reserve to certain extent, all these are present across the Tarai belt. Even Pilibhit Tiger Reserve, that also is situated in that belt. Now, recently, the latest elephant reserve which has been declared by the country is the Tarai Elephant Reserve, one of the largest elephant reserves in the country. And basically, the aim of it is also in the northern portion of Uttar Pradesh, bounding the region of Nepal. Now, in that area of Tarai Belt, basically you will also find the presence of animals such as rhinos and so on, as is envisaged in that region. So, very luxurious growth of vegetation, very significant abundance of wildlife also. Okay. In Nepal, I saw Bhabar. Yes. In Nepal, you would be able to see many different kinds of landforms. For example, alluvial fans also is something which is very significantly discernible in Nepal, not so significantly discernible in our land areas, but in Nepal you will be able to figure out these tracks of alluvial fans. Then even the older and newer deposit, it is not so much developed, but as you come to the southern part of Nepal around the region of Birganj and so on, you will be able to figure out the new and the old deposits. Okay, so now after this, when we talk about the alluvial plains, so it is divided into Khadar and Bhangar. Bhangar is the older alluvium along the river beds forming terraces that is high away from the river channel. That is where the Bhangar exists. And they are impregnated with calcareous concretions where, as I told you, the particles, they compress each other, and the lower ones, due to the overlying pressure of it, the lower ones, they start secreting some amount of liquid calcium, etc., whatever minerals that they are carrying, and that joins multiple particles together. So eventual end result is you have larger coarse grained particles. So Bhangar is not very fertile, not very fertile, poor in air and moisture retention. Significantly poor in air and moisture retention. So that is why only coarse grain crops can also be grown here. Okay. Now, then we come across to the Thar Desert, the Indian desert. Across the western part of the country, we have the Thar Desert. Now, when we talk about the Thar Desert here, this is a desert which extends even into the region of Rajasthan. Okay. Now, Thar has not always been a desert. I have been repeatedly telling you this from the first class itself, whenever we have been studying about geomorphology, that Thar has not always been a desert. Formation of a desert in the Thar region has been a very recent phenomena. Only after India has reached this particular location, only then would you observe the creation and the formation of this Thar desert. So basically, the existence of desert in the region of Rajasthan is purely an attribute due to the alignment or the orientation of the Aravalis. If you observe the Aravali ranges, they continue somewhat like this. Historically, they would continue up till Delhi and furthermore up till the region of Haridwar as well, historically. But that is not the present scenario anymore. So now you have remnants of Aravali extending up till the region of Delhi, what is also referred to as the Delhi Ridge. But then Aravalis are much reduced as compared to what they were earlier at one point of time. The Aravalis, which are clearly the oldest fold mountains in India, these Aravalis at one point of time were so very high, so very tall and lofty, that many of them, or almost significant number of them, would be permanently covered under thick blanket of ice and snow. And the melting of ice and snow would feed the numerous rivers which would originate from this area. But obviously, since those time, millions of years back, billions of years back, there has been a general denudation, erosion, and now the Aravalis are basically a remnant of what they were at one point of time. Now, as the Indian plate did collide with the Eurasian landmass, then for some time, the water of the Tethys Sea entered into this particular area. And for some time, this region was under the partial coverage of water. Right? You had a shallow sea, which is said to have developed in this particular region. Right? Now, that is the reason why in this area of Rajasthan, you will still find the presence of crude oil, that is petroleum, natural gas, all of that, which tells you that this area had been underwater, is something that you find to be present in this region. Okay, so that is the what happened historically in this area. But then, if we come to the present day, so if it was not a desert, why is it now a desert? So basically, when you take a look at the present alignment or the orientation of the Aravallis, so here, this is the region which is frequented by the monsoon winds. So the Arabian Sea branch of monsoon, if you look at, so Arabian Sea branch of monsoon moves parallel to the Aravallis. As they crisscross the Aravallis, in the region of Aravallis, maybe they will cause some amount of precipitation, right? But for most of the part, they will be simply moving parallel to the Aravallis. So, reasons for being a desert. So, you have Arabian Sea branch of monsoon moves parallel to the Aravallis, hence no rains in western Rajasthan. Okay, hence there is no rainfall in the western portion of Rajasthan. And then after that, when we talk about the Bay of Bengal branch of monsoon, because India is impacted by both branches of monsoon. So, Bay of Bengal branch of monsoon, when you talk about, now for that Bay of Bengal branch of monsoon, western Rajasthan lies in the rain shadow zone or the leeward side. So while it can cause some amount of rainfall, very little amount of rainfall in the eastern part of Rajasthan, western Rajasthan is completely deprived of any kind of rainfall whatsoever. So western Rajasthan lies in the rain shadow zone of Aravallis, and hence for the Bay of Bengal, Bengal branch of monsoon, and hence no rain. Okay, that is a feature that you will observe. Ganesh, is Tethys Sea cover entire Rajasthan or some portions of it? The western part of it is said to have been covered by Tethys Sea. Okay. If Arabian Sea branch moves over Thar, so simply if you have, so you need those winds to be stopped, right? If the Aravallis would have been, let's suppose, like this, then these winds would have caused orographic rainfall here. Please understand, in case when we talk about the Himalayas and when we talk about the Indian monsoon, had the Himalayas not been there, despite of all the moisture brought by the Bay of Bengal and the Arabian Sea winds, the northern plains would not have received rainfall. It would have simply passed on to the north. So the presence of Himalayas ensures orographic rainfall. Okay. Yes, if Himalayas would not have been there, the entirety of northern plains could have very well been a desert. So I think, Akash, the aspect of climatology is where you need to understand that rainfall. It is not as if moist winds are coming over a region, the region will experience rain. No, if that would have been the case, then there would have hardly been any deserts out there in the world. So you need a stopping factor for those winds to stop and those vapor to be allowed to condense to form the cloud so that they can bring rains. So that is absent. Okay. In Punjab, the rainfall which is caused is orographic. In Punjab, you have the Punjab and Himachal Himalayas. So the Punjab and Himachal Himalayas which are present here, that causes rainfall in Punjab. So it is not as if here you have the mountain, the rainfall will be caused here only. No. If this is going to stop the winds, the entire portion is going to receive rainfall. 80% of rainfall in India is orographic. Absolutely, yes. Why India is not taking crude oil present there? India is extracting the oil from that region, but obviously the oil deposits are nowhere as much to fulfill our overall demands, and there are certain blocks. So that is where Cairn Energy, which later on got mired in so much amount of controversy. This is the region of Rajasthan, that is the northwestern portion of Rajasthan, the Shekhawati region as it is referred to. So that would be rich in the crude oil and natural gas. So more exploration is also being carried out and some amount of extraction is also being carried out. But obviously, it is not as rich as you would experience in the region of Middle Eastern countries. Not understood the western part of Rajasthan as a rain shadow region. Okay. So for the Bay of Bengal branch of monsoon, how is it that the Bay of Bengal branch of monsoon can bring rainfall? So for the Bay of Bengal branch of monsoon, as they come over, these are your Aravallis. So the eastern side of the Aravallis will be the windward side. It is the windward side which will receive rainfall, right? So think about it. If this is your eastern part, this is your eastern part, this is your western part. Here the Bay of Bengal branch of monsoon is coming. So here it will rise up, cause rainfall in this entire area. So the region around Kota, etc., they will receive rainfall. But then here the winds will become dry and also warm. So that is the entire region. This is the entire region which turns out to be, for the Bay of Bengal branch of monsoon, this region turns out to be rain shadow zone. Is that understood now? What is rain shadow zone? Okay. So now we move ahead here. We take a look at the Indian desert. It lies to the northwest of the Aravalli Hills. It is a land of undulating topography with lot of dunes and barchans. Remember, we had studied barchans as well. So many of these barchans, along with the mushroom table rocks or the mushroom structures that you observe, all of them, they get created. So you have low rainfall below 150 per year, around 15 centimeter per year, very low rainfall, xerophytic vegetation is something which is observed in the desert areas. Xerophytic vegetation is observed in these areas. Now, this is also known as Marusthali, where nothing grows. So that is where the name is derived from, where nothing grows significantly. And the desert features here are mushroom rocks, shifting dunes. Remember the types of dunes that we studied: transverse dunes, longitudinal dunes, star-shaped dunes, barchans. So all these will be present here. And in few places, oasis, that is in the midst of the desert, you will have some amount of pool of water also getting created, where you will have some vegetation in that immediate vicinity, but that is it. So that is something that you find as a feature of Thar desert. Now, after the Thar desert, Yes, Pranay, perfect. It is the home for nocturnal animals. After the Thar Desert, we come to the portion of the Peninsular Plateau. Now, Peninsular Plateau is not only amongst the oldest landforms, easily the oldest landform in India, it is amongst the oldest landform across the entirety of the globe. Okay, that is something that you observe for the Peninsular Plateau, amongst the oldest landforms across the globe. Recent researchers have indicated that the regions such as Chota Nagpur Plateau, Bastar Plateau, these could very well have been the first land masses ever created on planet Earth. So that tells you how old this region actually is. Okay, so here what we are going to talk about is the formation of the Peninsular Plateau. But before that, what is a plateau? Plateau is an elevated flat table land-like structure. So the plateau overall, when we talk about the Peninsular Plateau here, this is your region of Peninsular Plateau. So you have a flat table land-like structure with steeper sides. So these are your Western Ghats and Eastern Ghats. There also you have the hills also, and there you have the presence of the Eastern Ghats. Now this plateau has been created because of volcanic eruptions. The origin is ascribable to volcanic events. But these volcanic events have happened billions of years back. Right, based upon that, you have the classification of the rock system in this place as well. You have the Archean rocks, the Purana rock system, the Dharwad rock system, etc. Not very much required for your general studies. The Gondwana rock system, etc. Not required for your general studies at all. But for a brief moment, I want you to open your imagination to the possibility that how can the landmass get created? So when we talk about creation of a new landmass, how does a new landmass come into existence? It is purely and mostly by virtue of volcanic eruption, isn't it? You have the volcanic eruption which leads to the creation of a landmass. Now, when we talk about the landmasses such as India, a large country like India, or a large country like, let's suppose, a continent like Africa or Asia, how do you think they would have been created? Do you think there would have been continuous volcanic eruption leading to the formation of an entire continent like Africa, Americas, North America, South America, like that? Do you think that would have happened? No. That is not the process how. You cannot have a landmass created of width of thousands of kilometers by a single volcanic eruption. No. So what actually happens is that you have creation of smaller individual pockets of land. These pockets of land, which are referred to as cratons, by the way, these get together. These start combining together. These start joining together. And when they will join, they will collide. They will follow the exact process of the plate tectonics that we know about. That upon convergence, they will also create folds. Upon convergence, you will also have certain areas which will observe the presence of volcanic eruption, etc. Everything will happen, but one piece at a time. So you have these small building blocks of these continents which start coming together. And together they form a larger continent or a subcontinent. So that is also how the Peninsula Plateau got created or came into existence. Here, when we talk about the building blocks, these building blocks are referred to as cratons. Or let me write it here. Building blocks of continents. Okay, that is what you have as cratons. Now, by the way, this is again something that you won't find in your reference books. So if you want to understand it, kindly pay attention here. So, as the researchers have indicated with the latest research happening in November 2021, the research paper has indicated that amongst the first landforms which got created was basically the Chota Nagpur Plateau, the region of Jharkhand, associated areas around western part of West Bengal, some portion of Odisha. So that is where you had initially the creation of Chota Nagpur Craton. Okay. Now, after some time, you had the creation of another such landmass, obviously due to volcanic eruption, in the form of Bastar Plateau. That also got created. The size of the Chota Nagpur Plateau obviously is significantly larger in comparison. Okay. Then this continued to stay for, because this has been created billions of years back. So this continued to stay for many millions of years like this. And then you also had the creation of land masses in the region of present day Karnataka. There also you had the presence and the creation of a landmass, the Karnataka Plateau. Now, in the time moment between them, obviously, when you have the evolution of landmass which has remained stable for millions of years, hundreds of millions of years, obviously you will observe the movement of rivers in between. You would observe the movement of rivers in between. Now, what these rivers would do, they would start depositing the sediments in between them, right? They would start depositing sediments in between. And because of that, you would have the continuation or a continuity of landmass in this entirety of the area. They would create those sedimentary patterns. Now, at the same time, almost around 2 billion years back, it is estimated, you had a landmass in the region around Aravallis, and that landmass actually collided with a water body. You had what we refer to as the oceanic continental convergence. So that convergence would have happened, and that created the old fold mountains in the form of Aravallis. So that is how you had the existence or the creation of Aravali ranges. And then after that, you had basically the Bundelkhand craton also got created. And basically, periodic volcanic eruption, as well as you had the sediments created by the rivers in this region, that joined the entire region together. Okay, so the evolution of land mass did not happen at one go. You had these multiple stages in between. So here, if I take you to this map, first of all, you had the creation of this Chota Nagpur craton. This was your Chota Nagpur craton. Then you had the Bastar craton. Bastar craton. Then after that, you also have the Karnataka plateau here. Karnataka plateau also got created. Then after that here, meanwhile, you also had the Aravalis. And you also had the region of Bundelkhand. These are basically the older areas, very old areas. Okay, very, very old areas which basically got created, came into existence. Now, this is how you had the preliminary landform to be appearing to look like. In the meanwhile, in the regions in between, obviously you had deposits carried out by the rivers, you had some volcanic deposits, etc., which would basically make this landform a continuous feature, a continuity in general. But here, if you would observe it further, then this was still not completed in a sense. Then came around the phase of 120 million years back, when the Indian landmass started moving away from the Gondwana land. And we have seen earlier also that when the Indian landmass was moving away, at that point of time, you basically had even the portion of Madagascar, which was very much attached with the Indian landmass. Madagascar was very much attached to the western coast of Indian landmass at that point of time. So as this was moving, it was moving north with a very rapid pace. So think about it for a better pictorial representation. Think about it in the terms here. Let's suppose the Indian landmass is moving. Now, as this landmass came over the region of Reunion Islands, the Reunion Island hotspot, Reunion Island hotspot. It is a volcanic hotspot. Till today, the Reunion Island hotspot is very active. So as the Indian landmass was sliding over that region, obviously it is not the case that today morning Indian landmass is there, today evening Indian landmass would have crossed over. No, the movement took millions of years. So in the same region, it would have existed there for millions of years altogether, then moved ever so slightly north, again existed there for millions of years. So it is a slow movement. So when the Indian landmass was over the Reunion Islands, at that point of time, it was the western portion of the Indian landmass which was above the Reunion Islands. At that point of time, significant volcanicity was observed across the planet. Around 94 million years ago, you had volcanicity observed even in Atlantic, leading to the creation of various islands, and you had also significant volcanicity which was observed in the Reunion Islands. It is estimated that in that phase of volcanicity, Reunion Islands witnessed the exit of 1.5 lakh kilometer cube of lava and more. So it is not as if at one go all those materials came out. These were basically the basaltic lava. Basaltic lava, if you remember, it flows very, very easily. So from here, you had an outpouring of basaltic lava. Of basaltic lava, which flows very easily. That is why it is also regarded as flood basalt, that it almost floods like water. Now, that lava spread over a very vast and a large distance in this entirety of the area. Okay, it spread over this region. And because it was a basaltic one, so you can think about it that if, let's suppose, this would be the earlier landmass, on top of it, the lava deposits appeared like this. Then again, after, let's suppose, for thousands of years, hundreds of thousands of years, this remained. So you had water bodies which evolved over it, some amount of minerals came, but then again, you had another layer of deposits. So like that, spanned across few thousands of years, you had layer upon layer of these deposits happening. Now, on the sides of it, it would always appear to be somewhat like this. on the sides. It would also always give the appearance of a structure like a step-like feature. So these step-like feature, this is also what is referred to as trepen. Feature. This is known as trepen. And from here, the term which was derived was traps. And that is how you have the region being referred to as Deccan traps. Now, this Deccan trap has got in many areas kilometer or more of deposits of this flood basalt. Now, it is this particular flood basalt which breaks down, disintegrates to create which particular kind of soil? The flood basaltic rocks, when they disintegrate and weather, which kind of soil gets created? Very good. Black soil. So this is the region of the fertile black soil, where you have cotton cultivation which is carried out, groundnut cultivation which is carried out. In certain areas, even you will observe the cultivation of other types of oil seeds, maize, millets, that is also carried out in this entire region. So that is the region of your black soil. Now, it is during this phase, by the way, when you had multiple such eruptions creating that step-like feature and multiple such deposits of lava. So think about it. The ground surface would have hardened. It would have hardened quite significantly, isn't it? The ground surface would have become very, very tough. Now, as fresher lava, think about it as the western side of the Indian subcontinent. Now, as you had more lava which was trying to come up from the region of the Reunion Islands, it hit that hard land, very hard landform, which it was not able to push through, which it was not able to crack through. So, in that pressure, when you had all that magma hitting the land in the western part, it could not break the surface, but in the process, it uplifted the surface. Some portion of it solidified immediately underneath in the form of intrusive igneous rock, and that upended the surface. That is the reason why in Peninsular Plateau, generally you will find that the slope of the land is from west to east. That is a common feature, where the western edge of the Peninsular Plateau is higher as compared to the eastern edge of the Peninsular Plateau. That is because the lava simply could not break through, it simply rose up like this. So that created the slope. That is why majority of the rivers of the Peninsular Plateau, despite originating very close to the western or the Arabian Sea, you'll find majority of the rivers, they drain all the way and empty themselves into Bay of Bengal. Right? They drain all the way, they form a longer pattern, they form a longer route, and they empty themselves into the region of Bay of Bengal. And that is because here the slope of the land has been tilted. But still, the formation of Indian landmass, the present day and shape that we have, that was still not completed. It was still partial. Here, if you think about it, basically you had the Indian landmass. The shape of it was still different ever so slightly. Across the western margins, you had significant amount of landmass here. And then across the eastern portion, the Peninsula Plateau at one point of time did continue even in this area. Even this region was very much considered to be a part of the Peninsula Plateau. But now it is not. Right now, only this portion of the Meghalaya Plateau is considered to be a remnant of Peninsula Plateau. Rest of them are not. So what happened? So basically, when the Indian landmass did collide with the Eurasian landmass at that point of time, right? The impact of collision was so significant that you had multiple different cracks and fault lines which developed across the Indian landmass. One of the major crack which developed was across the western coast of India. A major crack developed here. And the portion to the left of this crack or fault line, it simply sunk down. Similarly, when we talk about the eastern part, here also, in this region, you had a crack which developed. And this portion of the plateau also underwent subsidence. Now, in the western part, the crack which developed and the land which underwent subsidence, that is what accounts for the very wide continental shelf that you observe across the western margin of the continents. So, that wide continental shelf is created because of that land undergoing subsidence, right? And across the eastern part, here also, due to the impact of the collision, significant amount of area underwent subsidence. This is what is referred to as the Malda Gap or the Rajmahal Garo Gap, because on one side of it you have the Rajmahal Hills here. This is where you have the Rajmahal Hills, and other side you have the Garo Khasi Jayantiya. So this portion where the land underwent subsidence, this is what is known as Malda Gap, after the district of West Bengal where you find this, or Rajmahal Garo Gap. It is after the creation of the Malda Gap and the Garo or the Rajmahal Garo Gap that the rivers which were draining into the area, including Brahmaputra, including River Ganga, they found a southern path. They found a path towards Bay of Bengal, and they started moving towards Bay of Bengal. And in that process, they carried out deposits. And it is those deposits that you observe in the region of West Bengal and Bangladesh. So, all the fertile deposits that you observe in the region of West Bengal, Bangladesh, etc., they have come into existence after the land in that region simply underwent subsidence. And then the river started depositing there. So, that is how eventually you had the evolution of the present landmass. So obviously, if you apply your logic for a brief moment of time, the oldest landmasses are which ones? The oldest landmasses: Chota Nagpur Plateau, the Bastar Plateau, Karnataka Plateau, region of Bundelkhand, and the Aravali's. Even the Deccan Traps, the deposition of lava has been occurring for quite significantly later point of time as well, almost around 78 to 80 million years ago. Till that point of time, you had the deposition of this lava which was continuously happening. Now, in the older landforms, obviously created due to volcanic eruption, the top portion has been eroded and weathered because it has been created billions of years ago. So the top portion has been eroded, and the lower mineral rich regions, they are now closer to the surface. That is why mineral extraction is made possible from the regions of Jharkhand, Odisha, parts of West Bengal, Chhattisgarh quite prominently, Karnataka quite significantly, portions of Andhra Pradesh, Telangana, then some portions of Rajasthan, Madhya Pradesh. These are the areas from where you can extract a lot of minerals, and majority of the mines of our country are situated in this area, because these are the areas having rocks significantly rich in these minerals, where the top portion has been eroded and now the bottom portion is exposed. Okay, I hope this is understood. Yes, Pranay, correct. Right? I hope no doubt in this. So here, rising from a height of 150 meter above the river plains to an elevation of 600 to 900 meter is the irregular triangle known as the Peninsular Plateau, one of the oldest landforms created on Earth and easily the oldest landform in India. Now, it is having a volcanic origin, has underwent seasons, years, millions of years, and even billion years and more of erosional and weathering activities, due to which minerals lying deep inside the rocks can now be extracted, making the peninsular region very, very rich in terms of mineral deposits. Okay. Now, here, ideally, you should be aware about the names in different portions, which is the extent, where is it that the Malwa Plateau is situated, where is it that you will find the Bundelkhand region, Baghelkhand region, the region of Aravalis. That is something, Chota Nagpur Plateau, Bastar Plateau, that is something you should be sure of. But when we talk about the extent of the Peninsular Plateau, so in the northwestern side, it basically extends, or the northern side, it extends to the up till the Delhi ridge. So those of you living in Delhi, or those of you who have visited Delhi, when you travel from Delhi to Gurgaon, if ever you have, you will observe that you have a region which is referred to as the ridge area. A large area is referred to as the ridge area. Now, you don't have a hill or a mountain in that region, but you have slight upfolds or a kind of an uprised regions which are present. So that is the ridge area. That is a remnant of the Aravalis. Okay. All these areas used to be very densely vegetated when the Aravalis were having a significant amount of height. Now it is a different matter altogether that we are destroying Aravalis with our own hands. Aravalis, I hope we are aware, are getting destroyed almost on a daily basis due to mining and other activities, as you have more chunk of materials being taken away. And the mining in Aravalis and the destruction of Aravalis means that the Thar Desert now is expanding westward and northward. That is why Delhi, the outskirts of Delhi, that is why Haryana, in Madhya Pradesh also, you have very frequent occurrence of sandstorms, almost appearing as if a kind of desert apocalypse has come over. That is because you are destroying Aravalis. Okay. Now, the extension of it continues till Rajmahal Hills in the east, Gir Ranges in the west, Cardamom Hills in the south. It is at the region of Rajmahal Hills, by the way, where it is exactly at this pinch point. Observe here. This is where you have the Rajmahal Hills. Here is where the northern plains get narrower. Okay. So, northern plains become very narrow. Okay. And also, River Ganga takes a southern bend immediately after the Rajmahal Hills. Okay. Priya, can we say ancient Antarctica or Zealand emerging from underwater is kind of part of continent area which was sunk down some time back? Yes, in many of the cases that has also happened, but it is not consistent. It is not as if everywhere you have the same phenomena involved. For example, if I show you this particular area, in particular this region of Gujarat, now substantial portion, or in fact, just let me tell you how this has happened, how this portion, for a long period of time, this region of Gujarat, run of Kutch area, was not a part of the Indian mainland. It was in the form of few isolated islands here and there. right? Just like the islands that you observe in the region of Indonesia, Philippines, etc. A lot of small islands like that, you had these presence. But multiple rise and fall of sea level, then during various different earthquakes, you had areas or land areas which underwent subsidence permanently. You had land areas which suddenly emerged out of water. So due to that process, and also the rivers originating from Aravalis, they created those deposits that made the entire region of Gujarat a part of the larger landmass. So that is what you observe. That in every place you don't have the similar. For example, in 1819, you had a, not 2018, 2019, in 1819, almost 200 years back, you had a kind of a massive earthquake which occurred in the region of Kutch in Gujarat, which basically witnessed a large land area undergoing subsidence as a consequence of it, and also a small island of sorts suddenly emerging out of sea. So, in different places, lands have also emerged up. In many areas, lands have also went down. Okay. Pranay, hills are formed. Priya, I hope that is understood. And Pranay, hills are formed due to collisions of cratons. Yes. For example, when you talk about the Garjat Hills present in the region of Odisha, the Garjat Hills is said to have been created as a consequence of the Bastar and the Chota Nagpur craton getting together. And in fact, you would be very surprised to find out that at that point of time, billions of years back, you had the various different volcanic eruptions which would create these landforms, isn't it? Now, excuse me. Now, it was during that phase of volcanic eruptions, which would be very frequently observed in these areas, that you had the creation of hill like features on the sides here. That is what we still, even today, we refer to as the region of Eastern Ghats. So later on, when you will come across the fact that Eastern Ghats, they have a much lower height as compared to the Western Ghats. Many of the people, they are unable to fathom that. Many of the people, they are unable to realize that why is it the case? The reason is very simple. That Eastern Ghats, they got created millions of years back, if not billions of years back. So obviously, over a period of time, there would be a lot of denudation, a lot of erosion which would have happened. Whereas the Western Ghats, their exact formation and the entire formation of it was as recent as the formation of the Deccan Traps. So that is why the amount of weathering erosion that is experienced by them is going to be comparatively lesser. So that is why Western Ghats are continuous, whereas Eastern Ghats, which have been formed much earlier, significantly eroded. Okay. Uh, Rajmahal Hills in Jharkhand, yes, in the northeastern part of Jharkhand and the surrounding area of West Bengal. Satish. Uh, Pranay, sir, northern plains are narrow in the east because of more compression happened during continent-continent collision. Yes, a kind of a swiveling action where the eastern portion of India simply collided into the Burmese plate. That is why. Can we say in future that can happen again in Kutch area, like change of geographical structure in future? Absolutely yes. Why not? Absolutely yes. It is very active seismically, and the region of Kutch is at the boundary zone of three different plates. So absolutely yes, we can witness that. Okay. Now, after this, here we come to the extent of it. So the extent of it is even considered to be in the Shillong and Karbi Anglong plateau in the region of Meghalaya. So why? Because as I told you, at one point of time, it extended even up till this region. So that is why the Shillong Karbi Anglong plateau or the Meghalaya plateau is considered to be very much a part of the peninsular plateau system itself. Okay. Akash, sir, but plate tectonic theory says plate converges. Here, small cratons which are part of the plate converges. So, see, Akash, when we are talking about the formation or the existence of cratons, we are talking about a time period billions of years ago, 2.5 billion years ago. Even when we talk about the plate tectonics, Pangea, etc., first of all, plates are not permanent structures. I hope that you are aware of the fact that what you regard as a plate boundary today might absolutely not be a plate boundary going ahead 5 million years down the line, because a convection current might be in existence somewhere else, right? So the plate boundaries, they keep on changing quite rapidly, so they are not permanently fixed in any particular area. So that is why when we are talking about the cratons, these are the small areas, the small land masses. So imagine at one point of time, these were the lithospheric regions. Rest all area was covered in water. So these lithospheric regions were moving together or moving away from each other, undergoing that collision. So they were having the same principle involved as in plate tectonic theory. Later on, many of these, for example, at one point of time, Bastar and Chota Nagpur Craton were different land masses. They combined together and now you have one land mass. So similarly, when you talk about the entire of the Eurasian continent, the portion of Europe and the portion of the Asia, that is the area of Siberia, etc., they were different. For a substantial period of time, billions of years back, these were different, but they collided together and they became a Eurasian landmass or a Eurasian plate. So that is how the plate in itself is not a fixed quantity or an entity. So its boundary, its entity keeps on changing. Okay, I hope that is understood. Now, after that, when we talk about the peninsular plateau, it is ascribed with various different types of names, right? So it can be divided into Deccan Plateau, that is the region to the south. So including the Karnataka Plateau, including the Deccan Traps, everything included, that is a part of the Deccan Plateau. Then the Central Highlands, that is the region around Bundelkhand, Malwa Plateau, then the region of Vindhya, Satpura Ranges, Baghelkhand, Kaimur Hills, all of them, they became a part of, they are categorized into the part of the Central Highlands and the Northeastern Plateau, that is the Shillong and the Karbi Anglong region. Ideally, what you should do is, after the session, open up the atlas, take a look into which are the areas which basically, when we demarcate these regions, so where are these individual plateau structures situated? For example, Aravalis. Where are Aravalis situated? Aravalis will be situated somewhere here. This is where you will have the Aravalis, right? Then Vindhya range. Vindhyas and Satpura, they are situated in this area. In between the Vindhyas and Satpura, you have the Narmada Rift Valley system. Here you have the Malwa Plateau, which also consists of the black soil region. This is your Malwa Plateau. Then here you have the Bundelkhand region. Okay. This is your Malwa Plateau. Black soil is to be found in this area. Then after that, it is here that you will also find a highland-like structure, what is also referred to as the central upland or the Madhya Bharat Pathar. So this is the central upland region, slightly to the south of it. This is your Bundelkhand. This is your central upland. This is the region of Baghelkhand. Okay. Then furthermore, Chota Nagpur Plateau is situated here. Deccan Plateau. Out of that, if you consider Deccan Traps, so Deccan Traps will be situated here in the region from the area of some parts of Gujarat, Maharashtra, Madhya Pradesh, portions of Telangana, some portions of Karnataka, and some portions of Andhra Pradesh, very little portions of Andhra Pradesh as well. Here is where you have the Meghalaya Plateau. Here is where you will have the presence of the Telangana Plateau. Here is where you will have the Bastar Plateau or the Bastar Craton. Here is where you will have the Karnataka Plateau. Right. So that is basically the entire extent. So I want you to take a look at the atlas, locate these areas on the atlas in terms of in which states are they located. So there you can expect easily a match the following kind of a question to come, that for example UPSC has asked it earlier about the region of Baghelkhand, that Baghelkhand is present in which of these states. So the answer for that was Madhya Pradesh. So that is where you have to have some clue about the locational aspect of it. Okay. Now, after this, we come to the portion of Eastern and Western Ghats. Now, Eastern and Western Ghats, they basically, in a way, if you simplistically think about it, they give you an idea of the slope at the end of the plateau structure, because the plateau is a kind of a flat tableland like structure. So that is what they represent, the Ghat section. Now, the Eastern Ghats basically have been created much earlier. And here you will observe that they are not continuous. They have been degraded, weathered, eroded, and there are gaps created as the rivers they drain from west to east. Almost all the rivers drain from west to east. So as they drain from west to east, they have eroded the Eastern Ghats. For example, observe here in between the region where you have the Krishna and the Godavari basins, there you have an absence in the continuity of the Eastern Ghats. It is almost absent. Similarly, when you have the Kaveri River, that also creates a kind of a gap. So Eastern Ghats are not continuous, but Western Ghats are continuous. Western Ghats are basically a kind of an escarpment. We have already talked about the fact that how significant portion on the western margin of it underwent subsidence, and that is the one which creates the continental shelf area in the region of the Arabian Sea. So basically, when we talk about the region of the Western Ghats, so think about it that at one point of time, you had a scenario where at one point of time, the land mass was very much like this. Okay. And you had water. Now, during the time of convergence, you had the creation of the fault line and subsidence happened, so normal fault. So here you had the landmass which underwent subsidence. So as this landmass underwent subsidence, what was left behind was a steep wall-like feature formation, right? And the other area, it simply, or the other portion of it, simply went underwater. That forms the continental shelf across the western coastline. So this is why Western Ghats are referred to as an escarpment. Western Ghats, they are known as an escarpment. They are not referred to as hills or mountains. They are referred to as an escarpment. Okay, that is observed in the region of Western Ghats. Now here, if you observe another particular feature and something different here, you will come across a scenario where you will observe that across the eastern coastline, if this is west, this is east, across the eastern coastline, it is not the continental shelf which is very wide, but you will observe that water is deeper across the coastline in the western part. Water suddenly very close to the coastline is very deep. Now, what does that mean? Or where is it that it can be helpful? So when we talk about natural ports or harbors where the ships can come in, so basically the ships require what? The ships require deeper water so that they can come closer to the coast without touching the ground, right? That is the requirement of creating a harbor. Otherwise, anywhere and everywhere you can have the existence of a harbor. So, but the very reason that you require or the ships need to come in, unload, load. So for that, you need the water to be very deep, closer to the coastline. That condition is provided in the western coast. That is why western coastline of India is very naturally suited for the construction, for the presence of natural ports and harbors. Whereas across the eastern coastline, the natural condition, other than the region of Vishakhapatnam, the natural conditions don't exist for the creation of ports. That is why when you are creating a port structure across the eastern coastline, a lot of digging and dredging has to be done. For example, when Paradip port got created, when Haldia port got created, when you had the Kamrajar port which got created, all of this basically meant that you had a lot of digging and dredging which required to be done. Right? That was not the case across the western coastline. And India, by the way, the newest and the deepest port that India is developing is where? Is it across the east or the west? Or in which region of the country is India developing the newest port, which is going to be also one of the deepest ports that India has? Very good. Kerala, the Virinyam port in Kerala. And the reason that India is developing that Virinyam port is because the depth, natural depth of water very close to the coastline, what is also referred to as a draft, that is basically around 15 to 20 meters, right? Which is significant. 20 meters of depth right at the coastline is very significant, right? So that would allow larger vessels. I hope we are aware that till now, till today in India, we cannot receive the largest of the ships, the cargo vessels which are there. The largest of them, they are not received in India. Why? Because the infrastructure is not there, because the ports are not deep enough. So that is why what the largest of the ships, if they carry some material towards India, for India, what they do is they basically take berth in or they take a halt in either Colombo port or the Changi port in Singapore. From there, the materials are loaded into the smaller ships and then they are sent to India and ports such as JNPT and so on. So once you have the development of Virinyam port, India expects to virtually drag all the traffic out of Colombo port, and that is across the western coastline. Okay, so that is basically the aspect of natural ports and harbors. Yes, transshipment. Correct. Now, Western Ghats demarcates the westernmost extent of the Peninsula Plateau, forms an escarpment on its western slopes, thereby being able to influence rainfall across the western coast. It was formed due to submergence of part of the land into the sea. And locally, they are known by different names. For example, in the region of Maharashtra, Western Ghats are known by the name of Sahyadris, and Nilgiri Hills in Karnataka and Tamil Nadu, Anamalai and Cardamom Hills, furthermore, in Kerala as well. And they are comparatively higher in elevation and more continuous as compared to the stretches and the regions of Eastern Ghats. But when we talk about the Eastern Ghats, they run all the way from the region of Odisha to Andhra Pradesh to Tamil Nadu. Okay, so there is a kind of a continuity of formation. Now they are eroded and cut through by the four major rivers, that is Krishna, Godavari, Kaveri, and Mahanadi. They cut through these. Okay, and here you will have few of the important individual ranges such as Chevroy, Javdi. These are some of the important hill ranges. So Nalamala Hills in the region around Telangana. Then you have Palkonda Range, Mahendragiri Hills, Javdi Hills. These are the various hill ranges which are present. So the eastern and the western Ghats meet each other at the Nilgiri Hill region. That is why in the Nilgiri Hills, that is obviously, again, I don't need to say this, one of the most beautiful places when it comes to natural vegetation across the country. Very, very rich in terms of biodiversity across the country. So that Nilgiri Hill, which forms a confluence of the eastern and the western Ghats, is a rich center for biodiversity across the country. Okay? Now, after this, we come across to the coastal plains. So when we talk about the plains across the coastline or along the coastal area, now these plains are carried out or created because of the deposits which have been carried by the rivers, etc. Other than the eastern coast. In the eastern coast, obviously deposits by all the rivers such as Mahanadi, Krishna, Godavari, Kaveri, all of these are very large rivers. So they have created vast extent of these deposits across the eastern coastline. And historically, if you will observe, various different kingdoms, kings, they have always contested for control over eastern coastline in order to give boost to their agricultural activities. While across the western coastline, you had kingdoms such as Rashtrakutas, etc. They would always enter into some or the other battle thereby for the control of the western coast. It was largely because of trade. They wanted to control trade. That is why western coast was sought after. But eastern coast was always sought for cultivation. That is why when you talk about the Gangas, the Cholas, all these, they basically emerged quite prosperous because of the cultivation that they could carry out on the eastern coastal plain. Okay. Now, overall, when you take a look at the coastal plains, now eastern coastal plains, they are comparatively much wider as compared to the western coastal plains. Western coastal plains, they get wider at top, they get wider at bottom, but they get very narrow in between. And they have different names depending upon the region. For example, around the region of Gujarat, here, Gujarat and Maharashtra, they are known as the Kutch and the Kathiawar plains, where it is the widest. So this is what is referred to as the Kutch and the Kathiawar plains. And Kathiawar plains, where it is the widest. Then it gets narrowest in the region around Ratnagiri onwards when you go. That is where it is very, very narrow. That is where, as you are moving across the railway line in the Western Ghats, immediately you will be able to see the sea present parallel to you as well. So this is where it gets very narrow. This is what is referred to as the Konkan coastline. This is your Konkan coast. Okay. Furthermore, as you move to the further south, that is in the region of Karnataka coastline, there it is referred by the name Kanara coast. Then it gets very wide in the region around Kerala, and that is your Malabar coastline. Very good. Malabar coastline. By the way, Virinium port that I was talking about, Virinium port, it is because of the all the discussion that happened throughout the last year because of Virinium port. There was a lot of discussion moving around. I hope you are able to recall the various different protests which were happening about the various different allegations being leveled both at the state and the central government that they have taken money from the corporate. Now it was because of Virinium port, and there itself in the prelims crash course we had said, I had categorically made a remark that this time there can be a question asked about ports. So in the prelims examination, you had a match the following kind of a question about the ports, right? That which is the port which has got the largest container handling capacity, that was the JNPT, etc. So that means that UPSC gives you enough amount of inkling about the topics that it is going to refer to. Not the exact question that it is going to ask, but the topic that it is going to refer to. It is then up to you to study more about that topic, explore more about that topic. So, the Virinium port that I'm talking about, that is situated somewhere here in this area. Okay, so that is why it aims to take away all the business away from the Colombo port. Now, in the eastern coastline, also the naming is done. For example, the entire area up till the northern portion of Andhra Pradesh and Odisha coastline, this is referred to as northern Sarkars. Northern Sarkars. And within that, you have the Odisha coastline. That is also referred to as Utkal coast. That is also Utkal coast. Then after that, this is the region which is referred to as Coromandel Coast. Okay, that is your Coromandel Coast. Now, as I was telling you, now when we observe these particular, yes, Pranay, correct. So when we observe these coastlines, now in the western coastline, there has been a landmass which has underwent subsidence. It has undergone subsidence and submergence underwater. Across the eastern coastline, land has emerged above water due to the multiple rise and fall in sea level. Eastern coast, many portions have emerged above water. That is why eastern coastline is also referred to as an emergent coast, whereas the western coast is referred to as a submergent coast, because the eastern coast has been created as the land has emerged above water, and western coast has been created as the land has submerged. Right? So here, if you take a look at it, basically, in the western coast, Kandla port is present where? Gujarat, Mazgaon, JLN, Navasheva, Marmagao, Mangalore, Cochin are amongst the important ports. They have been divided regionally, that is the Kutch and the Kathiawar coast in Gujarat, Konkan coast in Maharashtra and Goa, and Malabar coast in Karnataka and Kerala. This is where it gets narrowest. It gets narrowest. It is broader above it and broader even below it. Okay. Now, the western coastal plains are narrow in the middle and get broader towards north and south. Now, in the western coastline, you won't observe delta formation, right? You will observe delta formation and estuary formation, both of them in the eastern coastline, but across the western coastline, no delta formation, only estuaries are created. Why? That is because of multiple reasons. First reason is that majority of the rivers drain from west to east. Okay. So obviously, majority of the delta formation is observed across the eastern coast because that is where the rivers move. Secondly, here the rivers, that is river Narmada and Tapi, amongst the larger rivers, river Narmada and Tapi, they drain into the Arabian Sea. So when we talk about the rivers such as Narmada and Tapi, they end up draining through the Rift Valley systems, isn't it? So they end up draining through Rift Valley in a pre-decided course and path. So when they are draining through Rift Valley system, obviously they won't carry that much amount of sediments that they can deposit. So Narmada and Tapi drain through Rift Valleys means very less materials carried. Okay, very little amount of materials which are carried over. Okay, and also you don't have enough space available across the western coastline where they could be accumulating these materials and depositing them. That is why you don't observe the delta formation happening in the western coastline. Rather, you will find estuary formation. So hence here estuary formation is predominant. Please understand, estuary formation you will observe in the eastern coast also. River Mahanadi, Godavari, they form estuaries in certain parts also. It is not as if estuaries are present only across the western coast. It is present across the eastern coast as well. But in western coast, you don't have delta, you only have estuaries. So estuaries are predominant. What are estuaries, by the way? For those of us who don't recall that, basically, if suppose this is the land area, let's suppose this is the land, this is your land, and this is your sea. So, and here is where a river is moving through. So here you have this as this portion is your estuary, where the sea and the river water, they end up meeting. Okay. So this is your estuary. Yes, Mahanadi also has braided streams. That is correct, Chinmay. Utkal coast is a subset of the northern Sarkars, Sidhya. And delta is a deposit which is created by the rivers as they meet the sea. That is a delta. Narmada flow from east to west. Here, they carry less amount of sediments because they are already moving through rift valley structures. Rift valley means the central point is depressed. So there won't be any significant materials carried due to vertical erosion. Whatever materials are carried from here and there, so there is not much scope for Narmada and Tapi to carry those materials which it can deposit. When you will erode more, you will be carrying more, and then you will be depositing more as well. But what if you are not eroding more? And what is the situation or the scenario when you won't be eroding more? When you are already moving at a lower depth. Okay. Western Ghats submerged more than the eastern. No, 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 no. But why Godavari Bhima rivers flows from west to east? No, Western Ghats did not get submerged. Land beyond the region got submerged, and that is what led to the creation of a steep wall like formation in the Western Ghats. It will be an absolute incorrect statement to say that Western Ghats have undergone submergence or subsidence. No, it is basically the land beyond that region which has undergone subsidence, and that is what has left the Western Ghats as a steep wall-like feature. That is why Western Ghats continues to remain higher or greater in height, and obviously the land was also uplifted at the time of the Reunion Islands itself. That is why the general slope of the land is from west to east. Okay. Yes, Pranay. More estuaries you will find in the eastern coastline. That is correct. Okay. Now, in the region of Malabar coastline, that is in the region of Kerala, you will find many low-lying areas from where the seawater enters in. And it forms various different channels where it can even merge with the river coming, small river coming from that area. Now, because of these low-lying areas and wherever the gap is present in the land, let's suppose the land is somewhat like this. It is so very low-lying. Let's suppose somewhere along this gap, the seawater enters in. It forms a long channel and might meet with a small river or a stream. So here you have a backward flow of seawater. Saline water is present, salty water is present. So these are what are also referred to as backwaters. If ever you get an opportunity to visit the region around Trivandrum, Kovalam, etc., that is the region dominated with backwaters, right? So that is where the seawater enters inland because of the low-lying feature of the land, that it doesn't have significant elevation. So that is where you have the backwaters, which is a distinguishing feature of the western coast. Here you have the very famous boat race which is organized in that year in that area, the famous Nehru Cup, which is held there also, which is basically held year after year, and participation happens with great amount of fanfare. So that is used, these backwaters, they are locally known as kayals, and they are used for fishing, inland navigation, and tourist location as it is. Okay, yes, Alapuya also, right? Even Alapuya and or Elepi, whatever you call, very significant and extensive backwaters. Upliftment in west is due to lava pushed upwards, yes, and subsidence due to crack by high plate speed and collision. Yes, perfect, Satnarayan. Perfect. The eastern coastal plain, they are known as the emergent coast because some portion has risen above water, above the sea, and they are broader as well. So this is an emergent and a broader coast. Well developed delta is formed because of the eastward flowing rivers into the Bay of Bengal. So you have very vast and extensive deltas created by Mahanadi, Godavari, Krishna, and Kaveri. And it is known as Coromandel Coast in Tamil Nadu, and further north, it is known as the Northern Sarkars. Okay. Now we come across the last of that physiographic division of India. That is the island groups that we have. Now, here also, we will follow the same approach. We will try to understand the formation of these islands. How is it that these islands came into existence? So, when we talk about it, so we know that Lakshadweep, we have two island groups, one in Arabian Sea, one in Bay of Bengal. Now, in the region of Arabian Sea, we have the presence of island of Lakshadweep. Now, Lakshadweep is an island which is coral in origin. So, Lakshadweep represents coral islands. Okay. So, we have seen that how coral islands get created, be it an atoll, be it a simple upliftment or accumulation of corals till they reach above water. So we have seen that how the coral islands get created. So Lakshadweep has its genesis, has its origin from the formation of the coral islands. But for Andaman Nicobar, I want you to observe this image for and the region of Andaman Nicobar. Now, obviously, all of us know about the location of Andaman Nicobar Islands, but more so, observe this arc here. It is a continuous one, isn't it? It extends to the north and even to the south of the Andaman group of islands, doesn't it? So, here, basically, what do you observe? You will observe that this has been created because of convergence. Convergence of what? The oceanic crust of the Indian plate with the oceanic crust of the Burmese plate. Both of them collided. As the Indian plate was moving north and pushing to the east, that is where the collision happened. And that is where you had, whenever oceanic and oceanic crust collides, you will have the creation of volcanic islands. That is the reason why you have the volcanic islands. And the only active volcano of India is situated here, the Barren Islands. In fact, when you take a look at the detailed geographical denotation of barren islands across the world is referred to as the northernmost volcanic eruption of the Indonesian arc, which tells you that basically this entire Indonesian region, the convergence of the Indian plate is happening across the eastern portion. So when we talk about Andaman Nicobar Islands, so Andaman Nicobar islands basically here they got created how? So you had an oceanic convergence. Okay, you had an oceanic convergence. What basically this meant was, or which oceanic convergence? The oceanic crust of Indian plate with the oceanic crust of Burmese plate. That created volcanic islands, few of them, or when we talk about the oceanic convergence, I hope we are able to understand that this oceanic convergence, whenever it will happen, then if this is the level of water, obviously in certain areas islands will get created, but you can also have the existence and the creation of seamount structures also, right? If the volcanism does not continue beyond that, you can have the existence of the seamounts also. So few of these seamounts have then been inhabited by the corals, and that has given rise to few of the coral island like structures as well. So few of the seamounts are inhabited by the corals, creating coral islands in the process. Okay, they end up creating coral islands in the entire process. So that is the reason why Andaman Nicobar still has the active volcanism, and the only active volcano in India is present in the region of Andaman Nicobar Islands. Okay, now after this we will come to the drainage system. But before that, and before starting with the portion of drainage system, we'll take a break. But before that, I want you to think about a particular problem statement, the question which is a part of the PYQ, and we'll talk about it. Why do, do the Himalayas experience more landslides as compared to Western Ghats? Think about it, have a mental mind makeup, and then we will come back. So we'll come back at around 4:30 and we'll continue. Okay, let's take a break. 4:30 and we will continue. Okay, any doubts that you have, we'll take it up at that point. A confirmation about the audio, please. Thank you. So I have answers given by Parshuram, Abhishek, Satyanarayan, Chinmay, and Sri Devi. So, very quickly, if we go through it, so Western Ghats emerged due to escarpment. Himalayas are due to continental convergence. They are seismically active, fair enough. Western Ghats are basaltic landmass and are very old. Himalayas are newly created, very good. Rivers like Indus, Ganga, Brahmaputra, and perennial rivers come down from Himalayas. In Western Ghats, you don't have that river movement, true. Cloudburst, such conditions, they are created over Himalayas mostly, and not so much in Western Ghats. Very good, Abhishek. Very well done. Chinmay, Himalaya has sedimentary rock, which meant to be eroded easily. Again, a good point. Tectonic events, snowfall, rainfall, human interference, high tourism, deforestation, major economic events, earthquake, as well impacting on ecological carrying capacity. Himalayas is a young fold mountain system, still its rocks are not settled, as well as high steepness is leading to more landslides. Very good. Sridevi, uh, Himalayan region, steep slope mountains, erosion by rivers, mining activities, developmental activities due to height, gravity effect is little bit less. Heavy rainfall, glacial lake outburst flood, earthquakes, snowfall, climate change, construction of dams, barriers lead to change in the river direction, sloping terrain. Good. Himalaya slope gradient is high in Himalayas. Pranay tectonic forces. Shiva due to flow of perennial rivers and continued erosion. Active margin, unconsolidated rocks. Ravi. For landslide, ample amount of water and rainfall is needed. Himalaya has more availability of water. Akash, good. Pranay, lack of natural vegetation. Good. Mining, Pavitra, correct. Availability of steep slope, correct. Uh, Himalayas are very prone to landslide due to continuous flow of river. Good. So if I were to compile the answers given by few of you, then that completes the entire requirement of the answer for this. But judging by the type of answers, I feel that you won't face any difficulty in formulating the answer for this question. So overall, when we think about the reasons, it is just a compilation of the reasons that you have given. Priya, more of human activities than the human capacity index. Okay, correct. So here, if I were to compile those, one of those would be Himalayas are active and unstable landmass. So that means earthquakes or seismic activities are frequently triggered, due to which there is loosening of the slope and the occurrence of landslides can be frequent. So seismic activities weaken the slope. Weaken the slope. Okay. Akansha, huge concentrated rainfall in certain pockets of the mountains. Correct. That is also correct. Okay. So this is one of the reasons. Second, hogback topography. Topography means steep slopes, right? Which is a condition for or requirement for the condition for significant amount of landslides. Then Himalayas have sedimentary rock systems rocks easy to erode. Okay. Then after that, significant cloud bursts cause in Himalayas. Cloudbursts sometimes also occur in Western Ghats, but the frequency and the intensity of cloudbursts observed in Himalayas is much higher. In Himalayas, create landslides, then after that, lack of vegetation in Himalayas, because Western Ghats, they are basically densely forested, whereas the Himalayas, they are not densely forested. Lack of vegetation in Himalayas means more materials or more loose soil. Okay. Then after that, construction activities in the Himalayan region, unsustained tourism, due to which also there is significant amount of construction which is done. For example, the highway systems, or here in construction, you can talk about the infrastructure construction, infra building in Himalayas. For example, the highway network like the Char Dham highway network, etc., railways, etc., which are being constructed. So they are constructed after digging through the slope. So that can weaken the slopes in those areas. Unsustainable tourism, more number of hotels, resorts, etc., are being built up in the steep sloped areas. So that weakens the slope structure furthermore. Then, significant number of river streams, large number of river streams provide water needed for slide. Then after that, we also have another condition, mining activities. Activities weaken the slope. Okay. Mining has been banned in Western Ghats, Jaswant. After the Kasturi Rangan Committee report and the Gadgil Committee report, mining has been put to a stall. Whereas in Himalayas, the mining activities in many areas are still being carried out, which weakens the slope. Right. So that is also, especially in the northeastern part of the country, that is what leads to significant amount of this landslides being triggered. So here, and Jaswant, you had also pointed out another fact, another couple of points, that more height means more gravitational pull. That also you can basically assemble it along with this particular fact of steep slope. So when you have a steep slope along with a greater height of the Himalayas, there's a greater tendency of a slide happening, provided if you have the loose materials present. Okay. Then, so these are your pointers. Okay. Hydro projects also, yes, you can talk about the fact that you have more hydro projects, due to which this region becomes unsustainable, that is unstable rather. The Himalayas, they become unstable, and that also triggers the weakening of the slope and general sliding down of materials. So you have around 9 points. So for each of the point, even if you write a couple of sentences, that should be more than sufficient for any kind of answer. You should have the ability to concise this answer in 150 words and also in 250 words. But it is absolutely a significant amount of pleasure to look at the number of people who have given the correct answer in this. So that tells me that if the basics are in place for many of you, which is a very good sign. UPSC has asked this question multiple times. It has changed the language here and there, but it has asked this question multiple times. Once it has asked this question in a 10 marker question, once it has asked this in 15 marker question. Earlier, when there used to be 20 marker question, there also UPSC has asked this. So UPSC basically is repeating it quite often. I tried writing it in 150 words in break. That is very impressive, mightily impressive. Good. I like the dedication, Jaswant. Now, after that, we come to the drainage systems. Priya, sir, then why government allowing hydro projects even when they know the afterwards effect? So, for example, recently Jamrani, Nainital. So that is where there is an issue. You don't have very large projects which are given a clearance anymore. You have the small run of the river hydroelectric project in which you don't require that much storage of water in a reservoir. See, when you create a dam like structure and a reservoir, that is when the seismic activities, landslides, etc., become very common. But when we talk about run of the river projects, generally implemented in the region of Jammu Kashmir, there you simply divert that river water into the tunnel, and by the force of the water you allow the running of the turbine. So that is still geologically still friendly. But then what has been found out that in many of the areas proper environmental impact assessment has not been carried out, so that needs to be done. But India is facing a scarcity in terms of electricity, the cleaner energy that is present. So that is why you will find that the government has given a go ahead for hydroelectric project generation or hydroelectricity generation even in the region of Arunachal Pradesh, dam building exercises in Arunachal Pradesh, Uttarakhand. But when you build dams in that area, you are exposing yourself to other kinds of vulnerabilities in terms of the uh, earthquakes also in that area. They can also become very, very frequent. Okay. Which type of diagram are expected that we should draw? In this particular image, a very simplistic diagram of a hogback to, in this type of question, a simple diagram of a hogback topography and a simple diagram of Western Ghats covered with trees, more than sufficient. Okay. As per the optimistic theory, can we write in conclusion government should not allow such projects? No. Never direct that the government should do this or should do that. The government should take due care and proper consideration before allowing larger hydroelectric projects, which can be a danger to the ecosystem in that area. That is how you put constructive criticism. If you say that the government should not do it, you are directing the government. Presently, you don't have the authority to be able to direct the government. That is why you are appearing for this examination. Once you clear the examination, then you can all say all these things. But as of now, government should have a much more deliberative stance. Government should think much more before passing this. So that kind of a suggestive recommendation should be provided. It is advisable to give examples like states. Yes, you can. You can always give examples of the various different states, obviously. Okay. So now we come to the portion of the drainage systems. Now, this is a portion which is relevant again, both for your prelims as well as for your mains examination. When we talk about the portion relevant for your prelims, now from this particular area, in prelims, you do get asked questions about the region of or the portions of rivers and tributaries, rivers and their tributaries. Then, for example, drainage patterns, Okay. Then, for example, sequent and insequent streams. Okay. So this is the kind of question that you get asked in the prelims from this area. In the mains, however, in the mains examination, you can expect questions about flooding of Himalayan rivers. Okay. Why is it that on an annual basis, frequently you experience flooding of the Himalayan rivers? That is something which is relevant. Then, after that, also interlinking of rivers. That is also, by the way, a question that UPSC has repeated time and time again, not only in the mains examination but also in the interview panel. Also, you would observe that UPSC has repeated this question multiple number of times. So these are the areas where UPSC is going to ask you question about, and sometimes it asks very generalistic question about conservation of water, for example. Right. These kind of simple questions can also be framed. Okay. Now here, we'll take a look first of all at the drainage systems. That is something we'll gain an idea about. And after that, we shall be delving into the details of the river systems of India. So first, when we talk about the drainage system, we are going to introduce ourselves to the basic concept of what is sequent river system, what is insequent, what do we mean by a kind of superimposed river system, antecedent, consequent, subsequent river system, what do we understand by drainage pattern, and then we will move over to the portion of India and river systems of India as well. So here, when we talk about the land, anywhere where a landmass gets created, so immediately after that, you will experience that in that particular region, after some time, you will also have the flow of water attained in the form of a channel, in the form of a small stream. Now, it is not always that the rivers need to get supplied by the melting of the ice and snow and glaciers. Many of the times, as for example, we observe in the peninsular part of the country, the rivers, they get their water because there is high amount of rainfall getting concentrated in one particular area or in one particular region. So that also means that rainfall can support the river systems, and it does support river systems in many parts of the world. So that is basically the characteristic. So as soon as a land, the topography of a region comes into existence or topography of a region develops, immediately after that, you will also find that the drainage system, the drainage patterns in that area also come for development. Now, here, first of all, the flow of water through well-defined channel is known as drainage, and the network of such channels is known as the drainage system. Okay, so the drainage system is basically the network of overall such channels which are in existence. Now they are governed by the what is the path that the rivers will follow, the streams, which path they will flow through. So that is governed by the topography of the land. That is what the relief features are. The gradient of the land, if the land or the slope is very steep or if the slope is very uh, gradual, so that also is a determining factor. Geological time period, how old the rock is, because in many of the cases when you have older sedimentary rocks, it is very easy to get them eroded. And in many of the cases where you have newer rock systems, igneous rocks, so igneous rocks very difficult to erode, right? So for example, when a river is flowing through a plain area, it can easily chart out its own way by forming the meanders, pathways, etc. But the same thing you cannot expect for a river which is flowing through, let's suppose, the peninsular part of the country, to the hardened landmass. There you cannot have a same kind of or a similar kind of expectation, right? So here, geological time scale, nature and structure of the rocks, amount of water flowing, periodicity of the flow as well, whether the water is going to flow in that region continuously or whether in that area, just a moment. So whether water is going to flow through that area continuously or whether that region experiences seasonal flow of water, that also ends up determining the characteristic of the river flow and the river channel. Now, a river actually drains the water collected from a specific area, and that area is a catchment area. What do we mean by that? So, for example, let's suppose we have a landmass. Let's suppose we consider a particular landmass. Okay, let's suppose. Now, from here, let us assume that you have a river system which is in flow. From here, let's suppose there is a river which starts to flow. Somewhere high up in the mountains, it comes down and it flows. Now, this river system which is flowing, let's assume that it will have tributaries as well. Let's assume there's a tributary coming from here and joining the river. Now, it is not going to be the case that if there is a rainfall or if there's water provided exactly at the river channel, there only the river will gain some water. No. Even if, let's suppose, there is rainfall which is observed in this area. Let's assume there is substantial amount of rainfall which is observed in this area. Now, what that means is that all the water which gets accumulated here in the form of the streams, the small streams, etc., they will also end up mixing with the river, meeting with the river. If there is, let's suppose, there is a kind of rainfall here. So from here also, water will get accumulated and will supply the water to the main river channel. So the entire region from which the water is collected and the water basically moves to the river, that entire region is referred to as the catchment area. Okay, so this entire area can be considered to be the catchment area of this particular river. Okay, so the river drains the water collected from a specific area, which is the catchment area. If you take a look at it, this particular image, observe here, the river is draining from this region. This is where the river is flowing. But if there is rainfall here, if there is rainfall here, if there is rainfall here, in any of these regions, if these regions receive rainfall, all that water will end up accumulating where? In the main river itself. So that is the catchment area of the river from which the river is getting or accumulating all the water. That is the catchment area. Okay. Now, the drainage basins, overall, they are divided from each other by topographical barriers. And those topographical barriers are referred to as watershed. Now, what is the meaning of it? So, for example, when we have, again, let us consider a landmass. Right. Now, if it rains in this particular region, where will the water flow? The water tends to flow in the area where the slope will allow it to flow, isn't it? Now, consecutively, if you think about it, let's suppose it is raining here. Water will flow in this area, in this particular direction, isn't it? So here, in a very close vicinity, the rainfall is happening, but the water flows in different directions. So that is because they are separated by an elevated landmass, which is a topographical barrier. This elevated landmass landmass forms the topographical barrier. And that is what is referred to as the watershed. That is what we have as watershed. So overall, if you were to observe this image back again, you would observe that observe this. This is a kind of a boundary, a differentiating boundary zone. So if there is a rainfall or any amount of flow, melting of ice, glacier, anything which happens on this side, it will lead to water coming in this particular river. And if you have the rainfall, etc., all these activities happening on the other side, there will be a different water flow or a different river generated because of this. So this is what is also referred to as a water divide. So these are also referred to as water divide, also known as water divide. Example, in the region around Ambala, you will observe up till that area, the Indus River system and the Ganga River system, they follow the same direction. But in the region or around Ambala, they simply diverge. So Ambala water divide, it is because in the region of Ambala, there is a topographical height that provides a kind of a barrier which separates these two water or drainage basins. So for example, the Ambala water divide, separates Indus River system and the Ganga River system. This is an example out of it. Okay. So that is about your basics of these drainage systems. Now, when the water flows, oftentimes it appears and always have this as a kind of a basic thing that water will always flow from a higher level to a lower level. Always there will, wherever there will be a height gradient, that is where the water will flow. So always it will follow the slope, isn't it? However, in certain cases, the water appears to be flowing in such a manner that it defies the slope of the land. It defies the general flow as per the slope. So, based upon that, you have the classification of the streams or the rivers into different types. You have the sequent streams and the insequent streams. So, this is based upon the flow pattern. So, here, based on the flow. So, when we talk about sequent streams, they appear to be following the slope of the land. They appear to follow the slope of land. Okay? Whereas the insequent, they appear to flow contradicting the slope of the land. Okay? Ravi, is Satpura Horst a watershed for Tapi and Narmada? It can be thought to be like that, yes. And Priya, hope this is used for the natural one only, not the human developed one, drainage system. As in that all the discussion that we are having for the natural streams only. We are not talking about artificial canals here. Okay, if that was your question. Okay. So now let us take a look at what do we mean by sequence streams and what do we mean by in-sequence streams. Sequence streams, they appear to follow the slope of the land. As is the slope, so is the flow of the water. And there you have the further subclassification into consequent and subsequent streams. Whereas when we talk about in-sequence streams, they appear to defy the slope. So you have the antecedent and the superimposed. So first of all, we'll take a look at the sequence streams, that is consequent and subsequent. So here, when we say consequent, consequent basically refers to those particular streams which would have come into existence immediately after the landform gets created, right? Immediately as the landform gets created, you will have a particular slope. So immediately after that, when a stream comes into existence, when the stream comes into flow, that is your consequent stream. So consequent streams are the streams whose course is a direct consequence of the original slope of the surface upon which it is developed, right? So again, I will take the same example. Let's suppose you have a mountain system here. Okay. Let's suppose. And from this area, you will observe that the river originates. The river originates from this area, let's suppose. And immediately, as the landform has come into existence, the river has also come into existence. And then the river simply follows the slope. Simply and straight away, it follows the slope of the land. Now, this is what is a consequent stream, that it has come into existence immediately and following the slope of the land immediately after the landform has come into existence. That is your consequent stream. Now, let's suppose after a few million years or after a few thousand years, or maybe even at the same time, you have the emergence of another particular small stream which ends up joining with the original river. Another stream which ends up joining with the river, right? Which becomes a tributary of the river. So that particular stream is said to be subsequent. This is your consequent stream, which is also referred to as the master stream or master consequent. So this is your consequent or master stream. This is your subsequent stream. So subsequent streams, these are those particular streams which would have come into existence either at a later point of time after the master consequent has been in existence, right? Then it would have come into existence, or it would have come at the same time, but then it ends up joining the consequent stream. That is your subsequent. Okay, so for example, if you consider River Ganga will be a consequent stream. Any of the tributaries of River Ganga, if you consider, that can be considered as a subsequent stream for River Ganga. Okay, so that is your sequent streams. Now, you have certain streams which appear in their flow pattern, appear to defy the slope of the land. So those are your insequent streams. So when we talk about insequent, streams here. So they are of two types, antecedent and superimposed. Antecedent means what? Something which has happened prior to an event, or something which is in existence prior to an event. So these particular streams, they or rivers, they appear to be cutting through mighty mountains. For example, take the case of river Indus, take the case of river Brahmaputra, take the case of river Satluj. They simply manage to cut through the Himalayas. Now, it is not possible for any particular river to have that much power, or even close to that much power, to be cutting through the mountains and then moving through. The only possible explanation is that these rivers would have been in existence even before the upliftment of the Himalayas. And as the rivers, they have kept their own position, around them the land has simply risen up. So that is what your antecedent streams are about. So they predate the upliftment of an upland or mountain across which they have maintained their present course or the present flow. Now, through continuous downcutting of their valleys. So, for example, if you consider a river which is flowing like this, now let's suppose due to significant amount of compression, the land area slowly and steadily gets folded. We have seen earlier in the case of entrenched or incised meanders as well, that when the land area gets compressed, what do you have? You will have a kind of a elevation folding which is happening, but the process of folding is going to be particularly slow. It is not going to be very, very fast. So this slow process of folding which will be observed, now that means the river systems which will be draining through here, the rivers, they maintain their original course, right? And any elevation which is happening across the river bed, the river is eroding that. It is the surrounding landmass which keeps on getting uplifted. So that is why it appears as if the river is cutting through it. But it is not so. The river is maintaining its original course. The land around it is getting uplifted. This is the reason why when river Indus moves through the Himalayas, it carves out a gorge where at the bottom of the gorge to the top of the mountain nearby, if you estimate the height, it is around 5.5 kilometers. When you talk about river Brahmaputra makes a sudden a sudden bend across the region of the Namcha Barwa. Now, Namcha Barwa, where the river Brahmaputra makes that bend, makes that turn, in that particular area, Namcha Barwa carves out a deep gorge, which is as deep as 7 kilometers from the top. So think about it. It has got the power to maintain its course, as all around it, the land gets degraded, the land gets denuded. So that is what is antecedent river. Then we have another kind of insequent river stream, and that is what is referred to as the superimposed river stream. But before again getting confused by the definition of the superimposed, understand why it is referred to as an insequent and what do we mean by superimposed stream. So, superimposed streams. Superimposed means you have kept something on top of an existing structure. That is what is the meaning of superimposed, isn't it? Can we say glacial river usually makes antecedent ones? Not all of them, but some of them, yes. Yes. So, understand this. When we talk about superimposed, so you have a landform which develops, a landform which comes into existence. And after some time, that particular landform is then modified by sedimentary deposits, by formation of sedimentary rocks. Any process can happen for the modification. So let us consider those examples. So let's suppose you have a landmass. Okay. Let's suppose you have a landmass like this. Now, let's assume this is the landmass made out of igneous rocks, very hard igneous rocks. Now, at this stage, if I were to ask you that which is the possible route through which a river will tend to flow, will it tend to flow through here if I mark it as 1, or will it tend to flow through here if I mark it as 2? Which is the most plausible area through which a river can flow and continue the down cutting? What do you think? Right? 1. 1 is the plausible area from which the river can flow, from which, or in the area in which the river can come into existence, isn't it? That is the region mostly where the river will be in existence, if the river would have flown at this point of time. But at this point of time, there is no river flow, no river in existence, etc. This is just a phase for the evolution of the landmass. Now, let's suppose that this landmass has been created 2 billion years back. Now, over a period of time, there will be further modification of the landmass also. You will have sedimentary deposits, etc., which will be carried out. Let's assume that over a period of time, this particular landmass okay, on top of it, you have sedimentary deposits. Let me represent it with a different color. Let's assume you have sedimentary deposits. And these sedimentary deposits have a shape somewhat like this. Okay. Let's assume. So, on top of the base rocks, these are your base rocks. Base rocks, that is the igneous rock system. This is your igneous rock system. Let's assume on top of the igneous rocks, these are your igneous rocks. And on top of that, you observe the sedimentary deposits. Now, if I were to ask you that in which area will we experience a natural flow of the river, if I were to give you these places similar to, and this is the place as 1, in which area naturally or normally will you expect the river to flow? 1 or 2? 2, isn't it? Mostly you will observe the river to be flowing through 2, right? Whereas in the earlier situation, you expected the river to flow through this depressed areas, but at that point of time, no river was in existence. The landmass further evolved, and as the landmass further evolved, now you will have the river flow in this region. River will be flowing through this area. Now, as the river is going to flow through this area, river is going to erode this as well, isn't it? It is going to continuously be able to erode this region, right? It is going to be continuously able to erode the igneous rock also. Now, if let's suppose a geologist today comes up and studies this, he will find that the igneous rock has been eroded from a region where it is actually at a higher elevation. And here, The igneous rock where it had the depression, there is no flow, no erosion. So that means had a river system come in existence at this point of time, it would have a different flow pattern altogether, different erosional structure altogether. But just because the river system has come at a later point of time, when the landmass has further evolved, and then the river system is in existence, it appears as if this river is superimposed in terms of its erosion. And when it is carrying out its erosion, it does not care whether the base rock has got a crest or a trough in that region. It will erode the base rock. So that is the superimposed. Now, once let us go through the definition and then we will come back to it. So when a river flowing over a softer rock stratum reaches the hard basal rocks, here hard base rocks, base rocks. Okay, here we have seen that the base rock is igneous rock system. Okay, so here what do we observe is that when the rock moves over a softer rock stratum, softer rock here is the sedimentary rock. Sedimentary rock, sedimentary rock, that is the softer rock in comparison, and the hard base rock continues to stay where it is. So, but continues to follow. So when a river flowing over a softer rock stratum reaches, after eroding, it reaches the hard rock level, it continues to follow the initial slope. It seems to have no relation with the hard rock bed or the slope of that hard rock bed. It appears to be significantly disjointed from the hard rock bed. This type of drainage is referred to as the superimposed drainage, where it appears that a new landform has been superimposed, and that is your superimposed drainage. Now, stream has enough erosive power that it cuts its way through any kind of bedrock, maintaining the former drainage pattern. Now, if you observe the image of the book, I understand that many of the times book image is better, but it is absolutely impossible to reproduce. So here, if you observe, this is what reflects the hard rock base, a kind of a upfold. Ideally, river would have never flown in this area if the river would have come into existence at this stage. No. But then the softer rock stratum has developed and then the river has come into existence. So as a result of that, what you have is basically, here observe, the river has come into existence, it is eroding and it is creating an eroded structure where the base rock appears to have an elevation. So in a way, the erosion is independent of the base rock, right? So that is why it appears to be superimposed. Okay, now apply your logic. This kind of drainage system, it is more commonly to be found in newer landforms, the landforms which have been created recently, or is it more prominently going to be found in the older landforms? What do you think? In the newer landforms which have been created recently or in the older landforms? Very good. Always the older one. That is why superimposed drainage is the one that you find in the region around Chota Nagpur Plateau, around some parts of peninsular India, where for millions and billions of years there has been the evolution of landform. On top of the existing igneous rock, you have sedimentary rock deposits which have been created. On top of that, maybe another layer, and then a river is coming into existence. Okay, so generally found to be existent in older landforms such as the Chota Nagpur Plateau. Subarnarekha River. Yes, very good. Subarnarekha River is one of those examples which indicates a superimposed drainage pattern. Example, Subarnarekha. Okay. Priya, thank you, sir, making such diagrams which are helping understand the topic easily. Wishing all the teachers can do the same to understand their. So I think not everybody has got the same leeway to draw the diagrams as a faculty of geography will have. Few of the subjects have that, but not all of them will have. So, but the main point or the agenda of it is you should be able to draw the diagrams. So there is no point if I draw the diagrams and you don't draw it in the answer copy. That is why I'm drawing diagrams as much as possible. Try to inculcate it in the answer copy. Okay. Now we come over to the portion of drainage pattern. Pattern. Pattern as a term in itself indicates what? The geometrical shape, right? So when a river flows, depending upon the rock type on which it is flowing, whether it is igneous, sedimentary, whether it is old or new, what is the slope characteristic, what is the power of erosion for the river, whether it can erode it or not. Depending upon that, the river will follow different kind of pathways and different types of patterns, geographical patterns. So that is what is dictated by the drainage pattern that we come across. So drainage patterns basically dependent upon rock types, erosional power, slope feature, amount of water carried, and so on, and also topography, obviously. So on these various factors, you have the drainage pattern which is arrived at. Now you have various different shapes and formations which the river they will observe as they end up flowing. For example, one of the most common type is the dendritic pattern. Dendritic means it is like a dendron, like a nerve cell. So it represents a kind of a pattern which is very similar to the root systems of the trees that you have. So for example, you would have come across the images or the rivers which end up joining from any which way possible wherever the slope allows it to come from. Isn't it? So when you have this kind of a river flow where it represents that of a dendron or a nerve cell, or basically the root systems of the trees, that is what is regarded as the dendritic pattern. Now, where is it that you will experience or expect the dendritic pattern? Where the rock bed is uniform. That means the streams can erode anywhere with the same power. So that is why the streams will always erode in those areas where they will have the ability to flow. So this is observed in those areas, observed in regions having uniform rock beds and uniform level of erosion. So generally what you will observe is that all the rivers which flow through the plain areas where you have a lot of deposits, there they will always have dendritic pattern, because the plain areas, they are basically made out of deposits of these sediments, and sediments Whether you erode it here or there, it is the same one and the same thing. That is why generally across sedimentary plains, you will observe almost all the rivers indicating a dendritic pattern. The image that you see is that of river Brahmaputra. River Brahmaputra, that too in the region of Tibet. There also you will observe this dendritic pattern in existence. Wherever possible, the streams can come into flow. So example, Indus, Godavari, Mahanadi, Krishna, Kaveri, Ganga also in significant portion, these follow dendritic pattern. Then you have a unique form of a pattern which is referred to as the trellis drainage pattern. Now, what do we understand by trellis drainage? So, trellis drainage is unique, is specific in the sense that here, if you observe this, if this is the flow pattern, now you will find that the primary tributaries, they are parallel to each other. Primary tributaries are the one which directly join the main river, and secondary tributaries are the ones which join the primary tributaries. So here you will find that the primary tributaries, they are parallel to each other. But the secondary tributaries, they join the primary tributaries at right angles. So in this, primary tributaries are parallel to each other. Secondary tributaries join the primaries at right angles. Okay, they will join the primary tributaries at right angle. That is what you will observe. Now, in which type of area will you experience this? So this is experienced in those regions where you have the alternate structure of hard and soft rock. So the hard rock is left uneroded and the soft rock is the one which keeps on getting eroded. So if I give you this example, observe this fourth image. In this fourth image, you will observe that this is the main flow of the river. Right. Now here, observe that the primary tributaries, they are joining at absolute right angles or parallel to each other. And the secondary tributaries, they are joining this as perpendicular. So this can only happen when you have an alternate presence of hard rock followed by a soft rock. Hard rock followed by a soft rock structure. So when this is common, the soft rock areas get eroded and the hard rock structures, they get left behind. Oftentimes, this is a resultant of the process of folding. Okay, many of us, we think about folding as a different manner, but let me tell you how folding can create this. So let's suppose you have a landmass like this. I will show it to you, just one, don't worry. Once again, I will show you. So here, break. Okay, can we finish the drainage pattern and then go for break? It won't take much time, another 10 minutes. Okay, I understand that staring on the camera can be pretty strenuous, but if you can withstand. Okay, good. So here, let's suppose you have the alternate placement or arrangement of the hard and the soft rock structure. Now let's assume this is hard rock followed by a soft rock structure. Let's assume this is again a hard rock followed by another soft rock structure, another hard rock. Now, once this gets compressed, that is when the folding will happen. Let's suppose this gets compressed. So as it gets compressed, the entire structure will get compressed. So what is the landform that you will observe? You will observe a landform somewhat like this. You will observe a kind of a landform somewhat like this. Isn't it? So here you will have hard rock, followed by soft rock, again followed by a hard rock, again followed by a soft rock, let's assume again followed by hard rock structure. Now this is a result of folding. Over a period of time, we have seen that the exogenic forces, they are also known as levelers. Wherever there is any kind of undulation, upliftment, etc., the exogenic forces, they will level it up always by wind action, by glacial action, by river action, by rainfall. It will also basically end up having a maintenance of the flattish structure. Can I mention the name hard and soft rock? Yes, obviously, yes. Now, let's suppose due to exogenic forces over a period of time, this gets leveled out. This gets leveled out. Now, when this gets leveled out, what is the structure that you will have? Observe the structure. Here you will have hard rock, followed by this is the region of soft rock, followed by a region of hard rock, followed by a region of soft rock, followed by another territory of hard rocks, followed by region of soft rock, hard, and soft. So there you attain a kind of an alternate arrangement or alternate bands of hard and soft rocks. So when the river flows, obviously it will be able to, the tributaries will be able to erode through the soft rock structure. And the hard rocks, they will get left behind undisturbed. So now if I again bring you back to this particular image, observe that in this image, wherever you have the hard rocks, wherever you have the presence of hard rocks, they are left almost untouched. Wherever you have the presence of soft rocks, they keep on getting eroded. So that is where you have the structural formation overall. Okay, I hope that is understood. So that is the case of trellis drainage pattern. So here it develops while where sedimentary rocks have been folded or tilted and then eroded to varying degrees depending upon the strength. Now the primary tributaries of rivers, they flow parallel to each other, and secondary tributaries, they join them at right angle. Example, you will observe in old fold regions, for example, in the Singhbhum region of the Chota Nagpur Plateau, you will experience this kind of a structure. So again, where you have the alternate arrangement of hard and soft rock, that in itself means that the land is very, very old, and then compressed and then getting eroded. Obviously, the land is very, very old. Okay. Now, then comes the radial drainage. Radial drainage is what? So, oftentimes from the mountain peaks, in particular the volcanic areas where now the obviously volcanism is not present anymore, but you have the presence of a mountain peak of sorts. Observe here, this one, this image. Now here, from one central peak, let's suppose rivers originate. Now, here one river, if it originates, it moves in different direction. Here another stream can move in different direction. Another stream can move in different direction. So from the same central point, the river is originating, but is moving in altogether different directions. So if you have a kind of a central hill or a mountain like this, so from the same region, the river will originate and it will continue to drain in very different directions altogether. Right? So that is your radial drainage. For example, when we talk about it, so volcanoes usually display excellent drainage, radial drainage in that area, and also commonly developed across the domes, laccoliths. Laccoliths also, if you remember, a kind of a dome-shaped feature. And here, for example, when you consider the region around Amarkantak in central part of India, now Amarkantak and the Amarkantak Hills is the region from where both Narmada as well as river Son, they originate very close to it. While river Narmada drains and moves westward to empty itself into the region of Arabian Sea, river Son drains northwards and meets with river Ganga. So that is why both of them here, they flow in different direction after originating from the same central point. So that is the example of radial drainage. Now, the exact opposite of that radial drainage is what you can consider as the centripetal. We have discussed earlier also, when we talk about centripetal force, we are basically talking about the rivers or the force acting towards the center. So when we talk about the centripetal drainage, generally what happens that as you come across the region with mountains on all different sides, let's assume, right? And if you have streams originating, small streams, not the very large rivers, if let's suppose you have the streams which originate and they drain into the central point or the central depression, that is what is centripetal drainage, where water comes in from various different sides and that accumulates in the central pool or a central depression. That is centripetal drainage system. So when we talk about centripetal, here you won't have very large rivers because large rivers will have a lot of water. How or where will you accumulate that much water? So generally, smaller streams in between the mountains in Nepal, even in Uttarakhand, in Himachal Pradesh, many of the areas you will find small pools in between and streams accumulating water in those streams. So that is your centripetal. So here it is similar to the radial drainage system with the only exception that the radial drainage flows out, but the centripetal comes in the region of a central depression. Okay, so example streams of Ladakh, Tibet, and the Bagmati and its tributaries in the case of Nepal also. Okay, and then does UPSC ask questions on this topic? Obviously, yes, my dear friend. Otherwise, I would not have taken the pain or the effort to cover this topic. Okay. So whenever you have any doubt that whether UPSC is going to ask from this topic or not, always assume a simple fact. If we are covering it in the class, in the session, means there's a probability that UPSC has either asked it or will ask it in the future. Otherwise, I don't want you to go through that pain, right? And I'm very clear in that none of us present here, I'm sure none of us will have the primary aim that we will become geographers in life. You are here because you want to clear civil services. So only that much attention you should pay to a subject which is adequate. So we will ensure that. Don't worry. Now, where does the water goes from depression? So you have these depression areas, deep depressions, where the water keeps on getting stored, keeps on getting accumulated. Maybe a small stream will carry it somewhere else from that. But generally, you have the water which keeps on getting stored there. And sometimes some of these streams, they carry it into the lower slopes. But that is the reason why I'm telling you that even for example, when you consider the Loktak Lake in Manipur, So that also is an accumulated water. That also is a characteristic of centripetal drainage, right? So in vast areas, small streams, very periodically, seasonally, they keep on accumulating the water. Yes, it can create large ponds in the process, correct. Now we come across to the pinnate drainage. The pinnate drainage pattern is observed or is experienced in those areas where, let's suppose, you have mountains or ridges or hills on both sides, and the river flows in between them. For example, the Rift Valley system. Now, in that case, the tributaries which will originate will join the main river, making very small angles. Okay, the tributaries which will be in existence, let's suppose here you have the various different mountains or the ridges, right, on both sides. Now, the tributaries which will originate, they will join this main river, making very small angles. So that is, they will come from an elevation and they will join it. So that is a pinnate drainage. It resembles that of the veins of a leaf. So when you have a leaf-like structure, so what do you observe there? In the case of the leaf, the veins of the leaf, they have this kind of a structure, right? So similarly, here also the tributaries, they end up joining at very small angles to the main river as they come down the elevation, as they come down the slope. So here Son and Narmada river at the later stages also they denote. Narmada particularly as it moves through the Rift Valley, it gets water from the surrounding Vindhyas and the Satpuras in the tributaries at a very small angle, and the small tributaries and the small streams that they make. So that is an example of the pinnate drainage pattern. Okay? Any doubts that we have? Or are we comfortable? Good. So now we will come to the next module, but we'll do that after the break. And we take a break, and we'll take a half an hour break. I think half an hour break should be sufficient. So half an hour break, and we'll come back at 6:15. Okay.